Hello, I am Li Hao. Welcome back to Evan of Code 2023. We are solving programming puzzles every day, and today we are on day 17. Can you imagine we have done this for 16 days and this is our 17th day? Okay, so let's take a look at what the puzzle for day 17 awaits for us. So day 17, Clumsy Crucible. The lava starts flowing rapidly once the lava production facility is operational. As you leave, the reindeer offers you a parachute, allowing you to quickly reach Gear Island. As you descend, your bird's eye view of Gear Island reveals why you had trouble finding anyone your way up. Half of Gear Island is empty, but the half below you is a giant factory city. You land near the gradually filling pool of lava at the base of your new lava fall. Lava ducts will eventually carry the lava throughout the city, but to make use of it immediately, elves are loading it into large crucibles on wheels. The crucibles are top-heavy and pushed by hand. Unfortunately, the crucibles become very difficult to steer at high speeds, and so it can be very hard to go in a straight line for very long. To get the desert island, the machine parts it needs as soon as possible. You need to find the best way to get the crucible from the lava pool to the machine parts factory. To do this, you need to minimize heat loss while choosing a route that doesn't require the crucible to go in a straight line for too long. Fortunately, the elves here have a map, which is your puzzle input, that uses traffic patterns, ambient temperature, and hundreds of parameters to calculate exactly how much heat loss can be expected for a crucible entering a particular city block. For example, this is the map of city blocks. Each city block is marked by a single digit that represents the amount of heat loss if the crucible enters that block. The starting point, the lava pool, is the top left city block. The destination, the machine parts factory, is the bottom right city block. Right, so this is the factory and this is the starting point. Because you already start in the top left block, you don't incur that block heat loss unless you leave that block and then return to it. Because it is very difficult to keep the top heavy crucible going in a straight line for very long, it can only move at most 3 blocks in a single direction before it must turn 90 degrees left or right. The crucible also can't reverse direction. After entering each city block, it may only turn left, continue straight, or turn right. One way to minimize heat loss is this path. Okay, so you go like this, and then here, like this, and then you go like this. So as you can see, after you turn, you can do 1, 2, 3 before you have to turn again, and then 1, 2, 3, you have to turn again, and then this is the path. This path never moves more than 3 consecutive blocks in the same direction, and it incurs a heat loss of only 102. Directing the crucible from the lava pool to the machine parts factory, but not moving more than the 3 consecutive blocks in the same direction. What is the latest heat loss it can occur? Okay, so I guess let's go to the code, jump to the code and figure out, right? So basically we have this map of city blocks, and then we need to find out the path that has the least amount of heat loss, and then the amount of heat loss that we get is the answer. Right, so let's go to our code editor. So as you can see over here, we have 16 days of code so far. We have solved the puzzle for 16 days, and all of this code is available on my GitHub, and you can find them on the link to the GitHub in the description below. Okay, so now we are at day 17. We need to initialize the inputs, which is this city block. And now the next thing we need to do is we need to figure out the path with, or the least amount of heat loss that we can incur by traversing through this map, right? So So how do we start, right? So I guess the first thing we can start by maybe intuition of thinking how we're gonna solve this puzzle is that this is the map, right? And also let me bring up a brush. We start from here and then we're gonna end here. So what we can do is we can start going from here and then we can go here as well. And then from here, we can possibly go from here to here. And of course, from here, we can also go down and go right. So from here, we slowly explore and expand and try to find the destination point. Of course, as you can see here, from the starting point, as we slowly expand, we have a lot of possible leads, right? It's possible come here, we can have here, we can have here, we can have this place, we have this place, right? So we will, for all of the leads, right? We find the one that is the least that takes the least effort, and then from there we try to expand from there, right? So for every leads, we try to expand from the shortest, the most least effort one to explore from there. Of course, after you explore, you will find that okay, maybe that lead will be not the shortest one. Then we slowly explore other leads as well, right? So and in that way, as we slowly explore, and then we greedily take the leads that takes the least effort. We explore from that first, and hopefully when we reach the destination, that will be the leads that takes the least effort, right? So there probably will also have other possible leads that haven't reached the destination, but we don't have to care it anymore, right? Because the only thing we need to care is find the least effort that we can take from the starting point to the ending location. Okay, so this is a bit of greedy kind of algorithm where we, as we explore, we greedily choose the leads that has the least effort, and then we start from there. Okay, this is kind of similar to A star algorithm, which is similar to your breadth search, but then we don't have to find all the location, all the destination point from the start, all the list. We don't have to explore the whole map to find the shortest distance in every destination from the starting point. We just need to find the shortest effort path from the starting end to the ending, to specific ending location. Okay, so hopefully you get the rough idea of how we want to do. Okay, and so now let's go on and gonna write our code and implement this. So let me zoom this out. So this is our input. So we're gonna start with let me see. Let's start with let's split this input into, to make it a map first. So input.split by new lines. This gives us an array of strings. Every line is one element of that array. But because a string is also kind of like array where you can index by the position of the character, right? So it's kind of like a map where you have a 2D, although it's only one dimension of array, and then each element is just a string. So here we have our map. Next thing is we need to figure out we have our starting point, right? And then this is our final destination. First thing is, let's get some dimension first. Okay, so the total rows is equals to map.length, and the total columns is equals to map0.length. Next is our starting point. Okay, so if we're gonna do this like this kind of like a depth first kind of search, we are going to have an array to record all the leads, right? So just now say we wanna have some leads, and then we're gonna find the leads that has the shortest effort, and then we will explore the possible leads, right? So okay, instead of calling arrays, I'm gonna call leads, or possible paths leads. I'm gonna call it leads. Okay, so right, the leads with the minimum hit loss. Okay, so for the leads, we start with our starting leads. We're gonna start with at the top left position, right? The column and the row is 0. And then from there, we are going to explore either towards the left or to the right. Right, so I guess we can write it this way. So we start from this. Let me see. Okay, we will have our leads. We're starting from the, so I'm gonna say the column is 0, row is 0. And then we probably will be going, we can assume where we come in. So we need to record some sort of like direction of where we're coming in, so that later on we know how to return left or right. Right, so from here, from this, we can come in either from the left or from the top. Right, so if we have the coming from top, then the d delta column is 0, and then delta row is 1, right? So positive row. And then the heat loss, because the first cell we don't really need to know the heat loss. So the heat loss for this case would be 0, starting as 0. And then the other leads is coming from the left, right? So we can have 1 and then 0. And then the next thing is we need to, when we move from a direction, we cannot move in that same direction more than 3 times in a row, right? So we need a counter to count how many times we have moved to this direction, right? So of course we're coming from the top, coming from the left into this 0, 0 position, but I don't think we need to count it in as moving. We have made a move, right? So the next time when we move towards the same direction, only we're gonna add the counter, we're gonna increment our counter. Okay, so after we have the leads, now the next thing is we need to keep while true, we are gonna find we're gonna sort through the leads and then find the one that has the lowest hit loss, and then we're gonna take that out, right? So first thing is we're gonna sort the lead by the right, in ascending order, maybe maybe in descending. Descending order, because we later on we need to pop it out. Dot pop. Okay, never mind. We do this. Leads dot pop. Current lead. Right, so we sort by descending order, and then so the last element should be the should have the hit loss that's the least amount of hit loss, and then we take it out. Pop is removing the item from the last element. We take it out, and then this is the lead that we have the row, column, delta row, hit loss, and count. Now we need to basically from this cell, we need to figure out where we can go next, right? So there are possible leads that we can go. We can go to continue the direction, or we can move to or we can turn, right? We can turn to left or right, but we cannot go back the direction, right? So so let me create an array of directions that we can possibly take. So possible directions is equals to so we have, it can be row is 1, column is 1, sorry, row 1, column row is negative, and we could also have a row is 0 where a column is 1 and negative 1. Okay, so these are the possible directions. So we're gonna loop through the possible directions and direction of, and then we're gonna add, we're gonna add this direction to our lead into add it to our lead, right? So explore from the current lead, explore all these possible directions. So some of these directions are actually I would say impossible. Okay, it depends. So and some of this direction we have to, if the direction, basically if this direction is totally opposite of where we're coming from, then it's an invalid direction because we cannot turn back, right? So for this case, if direction dot row equals to the current lead delta row multiplies by equals to the negative delta row, and also the direction column equals to, let me zoom out a bit, I think the font is a bit too big, current lead dot delta column. So basically this is saying that because the row and column is either 0 or 1 or negative 1, right? So if either of this is like a negative of, so either this is 0 or this is 0, right? So either of them, but anyway, if this is 0 and this is also like 0, and then the other one is 1 and then this is negative 1, so basically it's totally opposite directions. If this is the case, then we cannot move towards this direction because we cannot turn backwards. So I will say like this one, we cannot turn backwards. Okay, and all the other possible directions is possible. Okay, so so our next column and next row will be basically gonna add on to this current direction and current direction column, right? So the next column equals to direction the current lead dot column plus direction dot column. Next row equals to current row plus direction row. And we need to check boundary cases. So if next column is less than 0, or next row is less than 0, or next column is greater equals to the total columns, or the next row is greater equals to total rows, then we need to continue. Okay, we cannot proceed outside of the map. Okay, and then next thing is we need to make sure that if we're moving towards the same direction, the count cannot be greater than 3, right? We cannot we can at most move at most 3 blocks in the same direction, right? So I'm gonna say check first if it's same direction. Same direction is same direction if the current direction, current lead dot column delta column equals to current lead dot direction dot column, and the current lead delta row equals to the direction dot row. Basically, if this two is the same, then we are in the same direction, right? If is same direction and current lead dot count is already 3, then we can't continue, right? So we can't move towards this direction. We cannot move towards the same direction more than 3 times. So say continue. And now I guess we are moving towards we can move towards this direction. Then we're gonna add this new location into our possible leads. So our leads, we're gonna push in column is basically the next column, row is the next row, delta column is the direction dot column, delta row is the direction dot row, count is equals to direction, the current lead dot count, and plus, if it's same direction, I'm gonna plus 1, or else we plus I think write it this way easier. Is same direction, then it's basically count plus 1 or the current count. And lastly, the heat loss. Heat loss equals to the current lead heat loss plus basically where the current row and column is at, right? So basically it's the map, next row, next column. So we push this into our leads, and for all the possible directions that we can get after removing those directions that we cannot go, and then this is the possible leads that we have so far. And then we are going to continue with this, and then we're going to continue this outer loop, right? By basically finding the next least hit loss lead, and then we're going to start from there and try to explore all the possible different locations. And how do we know, how do we end this final this thing, right? Searching. I'm gonna call this loop as searching. We don't have the way to break this search list hit loss, right? We need to have a way to break out this outer while loop, right? We haven't break out from here, we just while through. So this one we are going to have basically if the here, right? So here we calculate next column, next row. And so if the next column equals to the total column minus 1, and the next row equals to the total rows minus 1, then we are going to break the search hit loss. So basically here we have found our solution, right? And our solution is basically we can print that out, right? Our solution is basically current lead plus the map next column, next row, next column. Okay. By the way, I just realized that the map is a array of strings. Probably not what we want. Because we want the numbers as value so that we can add to our hit loss like this, right? So probably that's not what we want. Let me make some change to here. So this one, for every line, we're actually gonna line dot split by empty string and then map every number to actual number. Right, so now the map is an array of numbers. Okay, so I guess that's it. So let's try to run our code and see whether it makes sense or it works. Let me clear. Node day 17, puzzle 1. And I guess we are stuck. Okay, so let's see where we are stuck at. So here, let's print out the leads that we have so far, and then see what are where we are going on every loop. Right. So here, whoa. Seems like we're just having too many possible place to go, right? We are at the okay. I'm not quite sure from here. I can't really tell whether we are doing okay or not. But if we don't print out, I guess it's hard to tell whether we are doing well, right? I just keep looping. Okay, how about I just print out the current lead and see whether is there any pattern that we see so far. Right, we are still stuck. We have column 4. Column 3, row 0, 1, 2, count 1. How come? Okay, so it seems like we are coming into the same place. We are going into the same place multiple times, right? Hold on. Let me make this much simpler and see whether we can easily see what's wrong with our code, right? So input equals to 1, 2, 3, 2, 2, 3, or 2, 3, 4, 3, 4, 5. Maybe 4, 5, 5, 6, 6, 7, 4, 5, 6, 7, 8. Okay, let's run and run this. Okay, we managed to hold on. Why do I print object? Where do I even print that? Oh, current lead dot hit loss. Okay, 35. Anyway, I guess we can't really tell whether we are on the right track, right? So maybe I have some path that has 1. 1, 1, 1, 1, 1. Right? And then we have a path that has 1, 2, 3, 4, 5, 6, 7, right? Which is correct. Okay, this is correct. But it seems like from the looks of it, we might be going into a Do we repeat? Just now I see like we print out something that's repeating. Let's see. No, we didn't repeat. We didn't go into the same place multiple times. Right, all of them are quite unique, I would say. I guess that's because the map on this case is much simpler. Like it's quite clear cut what is the shortest distance that we can find. But if we have a more complex map, then we might be going into the same tile in the same direction based of coming from a different place, but going into the same tile, the same direction multiple times, more than once, right? Yeah. Okay, so this could be coincidence because of how I create this map. Looks like this, but it is possible to go into the same place, into the same tile in the same direction and with the same number of count and the same hit loss. Right? In that case, we actually don't have to have the multiple leads because from there on you will also make the same possible turn from there on. Right? So maybe we need to clear up some you might want to use some memorization so that we prevent ourselves to go going into the same tile with the same directions again multiple times. Right. So one thing I can think of is maybe we can create a map visited equals to new set. Right. And okay, so and then this set we're gonna add. I'm going to create a function called visit a lead, and then let me see. Okay, so I guess this we can put here. Okay, the visit, and then when we do visit is we're gonna push the leads into the leads array, right? At the same time, we probably need to create a key based on a lead, right? So the lead could be lead.column, lead.row, lead dot delta column, lead dot delta row, lead dot hit loss, lead dot count. Okay, and then if the visited has this key, then we return, and else visited dot add key, and then also add this basically prevents from visiting the same lead again in the same direction. And then this is the actual visiting, right? So the leads itself can start with empty array, and then for coming from the top, we're gonna visit this one, and then this one is also we're gonna visit this as well, right? And same thing as previously. Before, instead of pushing, I'm gonna say visit. Okay, so in this case, let's try and run this. Guys, it's save this and run again. Sorry. I guess we don't have the duplicates again. We don't visit the same. Probably don't visit the same tile in the same direction again, right? Hopefully not anymore. Okay, so hopefully it's better. I think something just now I just realized halfway through. I might want to test out the logic whether we make a turn over here, right? So although this seems like the shortest path, like 7, but we can't go in the straight line more than 3 times in a row, right? So whether our code handles that, let's try and see. Okay, so it's 11, which means that we did make a turn somewhere, right? I'm not quite sure where. But it's definitely not 7, right? So 1, 2, 3, 4. Probably we go 4 in a row, and then plus. So we have 3 points plus 5 is 8, and then we go down from here, right? And then yeah. So I guess that's the shortest path so far. So let's get back to, let's try and use back the same input that was given from the example and see whether this time around it's better. So let's not printing out anything, and let's try and run our code. Still will take a while. I guess the sorting might take a while to do, and also the popping out will take a while to run. So we take roughly 12 seconds to run through, and then we get 123, which is the answer. And the actual answer is 100 and 2, right? So which is not what we're looking for. 102, 1, 2, 3. So something is not quite right with our solution. So each city block is marked by amount of hit loss. Crucible enters that starting point. The lava is top left. City block. Because you restart in the top left block, you don't incur that block hit loss unless you leave that block and then return to it, right? So we don't add this block. And then it's difficult to keep in a straight line for very long. You can move before it must turn 90 degrees left or right. Never moves more than 3 consecutive blocks in the same direction and incurs a hit loss of only 102. Okay, so but our code, we have incurred 123. This is a headache. Where did we go wrong? How do we fix this? Okay, let's see. I think you know what, to backtrack where we have come along so far along, I think we'll need to store the previous. I'm gonna keep track our previous path that we have done traveled so far, right? So path is an empty array. Path. I'm gonna keep track of the paths. Okay. So every time we're gonna push a new lead, we are actually gonna keep track the paths that we have traveled so far. So this is the current lead dot path, right? It's called path, and then also gonna pass in the lead current, the next column and next row. All right, hold on. Next row first, and then next column. Right. So once we found our answer, I'm gonna print out the current lead dot path as well. Let's try and run it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it takes longer. Then yeah, so now we have our path. So we start from 0, 0, and then we go to 0, 1. Right, we go to 0, 1, and then And then we go to 1 1, return down, and then 1 2. 1 2 and 0 2. So it's different. It is different from How should we solve this? How should we debug this one? It's a bit tricky now. It's different path, but I can't really know why this path is not correct, right? So let's see. Let me think. So one thing coming from top, coming from left. Let me have a subset of this input, and then I think first thing is I want to make sure that we are popping out the least amount of leads that the hit loss, that the minimum hit loss that we can get based on the leads that we have so far, right? That's the most important thing, because we stop once we found a path to the final map, for the final tile, right? Once we found it, we will stop. And we stop because we assume that the current lead hit loss is the minimum of so far, and we take it out. So this should be the one that gives us the shortest distance, right? So I think one thing we need to check is whether the sorting is correct and whether we're popping out the correct node. So but then it's too much things to print out. So let me simplify this by removing some columns. I think this is small enough. Okay, removing some columns and rows, and then at the same time I want to print out the leads array. Let's try and run this again. This is a bit too much. Let me see how we can read this. Okay, this is definitely a bit too much. I think we need to let me try to figure out a way to print this out nicely, right? So leads dot we're gonna create a function called print leads, and console log the current lead, console log some new line to differentiate. And for the print lead, for row column hit loss of leads, console log, gonna print it like this, row column hit loss. Let's try and see whether it makes sense. So this is, yeah, we have, every time when we sort, we have the nodes with the least number of hit loss at the end, right? And then we take out that node out. right? We take out that node out. We have quite a lot of 17s so far. Seems like we have quite a lot of 17s. So everything that is 17, we need to go and put it in and explore. Hit loss equals the map. Current hit loss equals to the map. Next row, next column. Row equals to column and direction row. Okay, so let's print out one by one to see where anything that we think might be wrong, right? So I think the logic wise seems correct, right? This way of finding things, but implementation wise, maybe something is wrong. Let's see. First thing is for every possible directions. Let's see. Possible directions is 1, -1, 1, -1. Right, so it's either moving up or down, and left or right. Right, so I think the possible directions sounds okay. Nothing fishy about it. Next thing is we're gonna find out if we go into possible. If we ever go into situation where we have turning backwards, we're gonna print that out and see whether those make sense. Right, so in situation where we cannot move forward is we're supposed to go up. We're moving up, but then we move down instead, right? Right? We can go up, right? So, and our situations where we looks correct so far, right? So if we are moving left, but then the direction says we need to move right, so which is incorrect, right? So these are paths that we cannot take, right? It looks okay, this logic. Okay, so I'm gonna say this logic looks okay so far. And then for the next column is the current lead column plus the direction column. Current lead row, direction column, direction row. Next column, next row, next column, next row. Okay, so here, let's print out the next column, next row, based on the direction and based on the current lead. This one, next column is 4, next row is 3. Then we're gonna move the new row. So hold on. Yeah, our column is 4, and then row is 2. We're gonna move to 3. Sounds correct, right? So the column is 1 with a minus. We'll move up. Row is 1. We are gonna stay the same row. Column row. We're gonna move plus 1 column. I think this logic looks so far so good. Nothing that I feel fishy about this. This one is the ending condition. It looks okay as well. Map next row, next column. Right? So every row and every column. Okay, looks okay as well. Same direction. The current lead direction And then we're gonna move the same direction. Okay, I think I know what's wrong. Okay, so if it's the same direction, we're gonna increment, but if we're gonna change direction, we're gonna reset to 1. Right, if we change the direction, that will be a new direction, and then that will be 1. Yeah, the first time we move in that direction. Okay. So let's try and let's come back and use the actual input. I'm gonna see whether we run into the right answer. Look, it takes a while for this such a small 101, 102. What? Okay. But let's take a look at our path whether it's correct, right? So we start with 0, 1, 0, 0, and 0, 1, and then move to 0, 2, and then we move to 0, and then we move to row 1. Hold on. This is, we are putting in row and column, right? So row 1, column 2, and then row 1, column 3, and row 1, column 4, row 1, column 5, and then move up 0, 5, and then we are moving row 0, 6, 7, 6, 7, 8, and then we move down 1, 8, 2, 8, 1, 8, 2, 8, and then we are 2, 9, 2, 10. So row 2, 9, 2, 10, and then we move down 3, 4, 5, right? 3, 4, 5, 3, 4, and 5, and then we 5, 11, and then 6, 11, 7, 11, 8, 11, right? So 5, and then we're gonna 6, 7, 8, and then we move to 8, 12, and then 9, 12, 10, 12, 9, 12, 10, 12, and then we have 11, 12. Hold on, are we missing some rows over here? Wait, how many rows do I have? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 rows. Right? So okay, so it should be 8, 12, 8, 9, 10, 11. So moving from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8. Right, so we have 8, 12, 9, 12, 10, 12, and we're not supposed to go to 11, 12. That's wrong. Okay, so something is a bit off in the logic. Let me take a look. Okay, I think we need to move this down a bit because we need to check that whether we can move to this tile in the same direction. If it's the same direction, we cannot move forward, then we need to move it down a bit. Okay, and let's see from here. 1. Okay, so we get 102, right? Which is the correct answer. Okay, so now we basically we move 10, 12, and then we have to 10, 11, 11, 11, and then 12, 11, and then move to the final tile, like this, right? So I guess, finally, Okay, so we can remove this and also remove this logic over here. Don't need to find out the paths anymore. Can clean out a bit. Remove this. As you can see here, I think understanding a logic and implement a logic is not too hard. But sometimes when we run into problems, it's a bit hard to figure out, especially we have so many data coming everywhere. It's a bit hard to trace this, right? So this time around, we just try to print and figure out something. But if really push comes to shove, we probably have to debug by stepping through the code one by one and figure things out, right? So now since we already have it works with our example input, let's put in the actual puzzle input. Whoa, which is a huge map. I'm gonna put it in here, and then I'm gonna run this code. I mean, for a small input, it takes a few seconds. For this large map, it will probably take a long time to figure out. Right? I'm gonna wait for a bit. I think because right now we are not using the most optimal data structure to store the leads, right? Because every time when we have a lead, we are pushing in and then we are do this sorting. We have to keep sorting this to give us the best to find the smallest lead that we have so far, right? And it hasn't been the most efficient way of doing this sorting, right? So if we're gonna be like this, we probably will need some sort of data structure, like things like priority queue or some like heap or something like that that can gives us the fastest way to push into the array, as well as fastest way for us to take out the leads that is the least number of hit loss, right? So it seems like it is taking a while, much longer than I suppose, than I expect, and I can't keep talking here forever and just waiting it to work. I guess now we need to think about how we can actually implement this priority queue, instead of using an array and then keep pushing, keep sorting this array, right? So we need let me think. Okay, so instead of like one thing I noticed that based on the things that we run just now, right? When we sort the hit loss, the number are actually very close to each other, and they are like the values, like there's a lot of repeating values. I guess that's also because of the map itself, right? We have like 1, 3, 1, 4, 5, and the numbers are very close to each other. Like the hit loss is like 16, a lot of 16s, a lot of 17, a lot of 18. I guess like we can create a data structure that is like approximate like a priority queue, but probably something simpler. Okay, so we're gonna first is we're gonna create a data structure over here first, right? Queue. That this data structure gives us a few things. One is that it will push something in, right? Push an item, and then also will allow us to pop out an item based for the least amount of pop out an item that has the least hit loss, right? So, and because just now I say like a lot of items, they are very, the values are very close to each other. I think like instead of storing them as an array, we can use something like a bin or buckets to store them. Right, so I'm gonna create a bucket, and then I also create hit loss values. So the idea is like this. Okay, so every time with an item, right? We will gonna add this item into the bucket, right? The bucket is basically bucketing based on the hit loss of the item. Okay, so if a bucket that has item dot hit loss, right? Then we're gonna add our get item dot hit loss dot push this item in. Okay, we're gonna add this item into our buckets. But if we don't have it, then which means this is a new hit loss value, right? So I'm gonna push this item dot hit loss value into the array that we have, like this. And then of course I'm gonna also gonna add this our item into our buckets. Okay, so what this hit loss values is actually an array of just the hit loss values, right? So because it is we have a lot of we have a lot of leads that has the same amount of hit loss. I think this is a good way to just store this into an array. So this array will be a small array only, right? So from here, right, what we can do is every time we push something in, we're also gonna sort this array. Hopefully this doesn't happen a lot of time, right? And it's not sorting the huge array of all the elements because they are a lot of elements that actually have the same amount of hit loss, so we don't have to sort this. Hopefully we don't sort this as many times as possible. Then when we want to pop an item, right, because this is sorted, first of all we need to, because we're gonna sort based on the value, we're gonna like this. Okay, so because it is sorted, basically what we can do is hit loss value, we can get the first element, which is the lowest hit loss, and we can go to the bucket to get this item, right? So I'm gonna say the lowest mean hit loss so far that we get is this value, and then we're gonna go to our bucket to get this value, okay, and get the pop out one element, right? Pop out any element, doesn't matter the order, I don't think it matters that much. Pop out an element from here, result, and this is what we're gonna return. Okay, we're gonna pop out and I'm gonna return. But why I need to do this is that if this one, if this one after we pop out dot length is 0, meaning like there's no more such hit loss value in our array, then we can actually take it out, right? Then we actually also need to remove it from the hit loss values. So what I mean, so we can we can delete this key, and also hit loss values, we can shift out this first element. Okay, we can remove the first element. So here we have our data structure that has a push and pop that hopefully returns the smallest hit loss that we can get, and then we also keep pushing, right? Hopefully it's much better. So here our leads is basically this thing, right? We can push our lead, and then we don't have to sort it again. We can directly pop out our leads to get the current lead, and hopefully this runs faster. Let's see. Before we try out, let's make sure that our code logic wise is correct. Let's come back to the example input and run. Okay, it feels much faster now, and answer is still correct, right? So here we are gonna use the actual puzzle. I'm gonna run and see whether we can get this faster now. Feels like it will still take a while because the priority queue that we implemented probably still not the best, but nonetheless, it's still helpful. Okay, we get okay, we run into set maximum size exceeded, so we probably explore uh too much leads that we explored, right? So hmm uh too many. So we need to prune early on as well if you keep running into. Okay, I think I know. I think we need to prevent ourselves to getting in a loop. Although I'm not sure why we would do that, but we need to prevent ourselves of getting into a loop, right? What I mean getting ourselves into a loop is, for example, if you see in this case, right, we might we might be going into circles, like we go like one, come down, and then two, and then four, and then we come down one, one, two, four. I mean, for um if a map is small enough, I think we do a few cycles, it's still okay, because maybe like we have a lot of small numbers over here, and this might be the shortest distance to travel, rather than take on like something like 8 and 9 and 7 and things like that, right? So it might be possible we are running into circles, and we want to prevent that from happening. um so I'm thinking maybe we should also keep track of where we have been to so far, and then for that particular things places that we have been to, we shouldn't go there again, right? Maybe that's helpful. I'm not sure. Let's try and see. So here I'm gonna create a for each of the lead. We're gonna have the visited as well, and it starts with the 00. So it shouldn't come back to the same node again, right? So here we have as well. And then when we visit the next one, I'm gonna say the visited is going to be um let me see, visited equals to new set visit the current lead dot visited, and then we also gonna add next column 00, right? So next row, comma, next column, right? And basically in our visit function, oh, I think let's do it this way. We clone this set, and then I think let's do it inside the visit function, right? So this one prevents us globally not going into the same tile in the same direction. Okay. Also prevent us from doing cyclical paths. So here, basically what we also can do is lead.visited.has coordinates equals to the lead.row, lead.column, right? If the lead.visited has this coordinate, then also we are gonna return, not visit. And then if not, we're gonna add this coordinate. Okay, so we start with empty set, and then when we visit, we're gonna push that into our set, right? Okay, let's see whether it's better. So it took us 25 seconds before we run into a maximum set size exceeded. So hopefully this time around we don't run into that. But it will take us longer probably because we have to copy and clone these sets for every leads that we're moving to, right? This is not free. It will take a while to create that space. So let's see whether this is better. It definitely feels like it's more than 25 seconds now, but whether it is going to the right direction or bad direction, we have no idea. The only thing I know is that it is still running, which means we didn't run into the same problem. But man, anywhere so the logic is correct. So I guess the next thing is to think about any place that we can optimize, right? I guess it's still this one, right? This, and then probably as we do the loop, places that we might have that might be taking up that might be slow us down is probably creating this object, creating new objects every time. I guess that might be something that would be slow. It feels like it's gonna take a while. I have a feeling, maybe, hear me out. I feel like maybe if we're gonna change this into a class instead of object literal, maybe accessing all the properties could be faster. I'm not quite sure. But nonetheless, I think it's worth a try. So I'm gonna create a class called lead. Sorry. I'm gonna create a class up here, because class probably don't have hoisting to be declared first. Called lead, and then constructor. So constructor, we have a column, a row, delta column, delta row, and then we have a count, and then lastly we have the hit loss and visited, right? Hit loss and visited. So each of this we are going to add to this dot equals dot like this. So this will be our class. And here, I'm gonna create new lead. basically remove all this. So we start with the column row, delta column, delta row, hit loss, count, visited, right? I think that's quite consistent. Column row, delta row, hit loss, count, visited. Over here, so column row, delta row, hit loss, count, and then visited. Okay, so I can basically replace this with this. Okay. This. And then here is the same thing. New lead column row, delta row, hit loss, count, visited. Like this. Okay. So we've changed our object literally object literal into class object, class instance, and let's see whether that brings us anywhere. Let's try run again. I think similarly it will take a while to run. Okay, I noticed something. Maybe I was thinking about the visit, right? We shouldn't go into the same tile, the same direction, for same number of time. And then we also add a hit loss in here, right? But after thinking a while, I realized that actually we don't have to have hit loss in this thing, right? Because we just need to be the same direction, same tile, same number of times on in that direction, and that's it. Why would I include the hit loss in this as a key? Right? If we are coming in again, but with a different hit loss, maybe a bigger number or the same number we already removed previously, right? But if a different number, that hit loss number must be a bigger number than it was when it first visited this tile, the same direction, with the same number of time in that direction, right? And if it's a bigger hit loss, and we go into the same tile again, which means it's probably something that we don't need, right? Because we shouldn't come in the same direction with a bigger number hit loss, and whatever it goes from there on, whatever it explore, it's most likely have a bigger hit loss than what it had previously. And so we can actually skip that one. So I'm going to remove this hit loss as a key, and let's try and run our puzzle again. Right? So hopefully this time around it's much faster. And it is. Oh my god, it takes 5 seconds, right? So previously it takes us like almost 5 minutes, it still couldn't come out something, right? So our memorization, we included something into our key which we shouldn't have to. We shouldn't have, right? So here we have 866. I'm going to copy it in and see whether this is the correct answer. And yes, that's the right answer. So we have solved our part 1. Okay, 1 gold star closer to our final case. And let's move on to part 2. So part 2, the crucibles of lava simply aren't large enough to provide an adequate supply of lava to the machine parts factory. Instead, the elves are going to upgrade to ultra crucibles. The ultra crucibles are even more difficult to steer than normal crucibles. Not only do they have trouble in going in a straight line, they also have trouble turning. So once the ultra crucible starts moving in a direction, it needs to move a minimum of 4 blocks in that direction before it can turn, and even before it can stop at the end. So however, it will eventually start to get wobbly. An ultra crucible can move a maximum of 10 consecutive blocks without turning. In a above example, an ultra crucible could follow this path to minimize hit loss. So it's the same logic, but then it can only move to the same direction. Has to move in the same direction at least 4 times, but at most 10 times, right? So I guess this give us much more examples to test out. So let us go back to our code. Let's copy this into puzzle 2. Okay, and let's come back and copy maybe this simple example over here and see whether we can get it right. Okay, so this is puzzle 2. So this is the puzzle. One thing that we need to do is, one thing we need to change is this logic, right? The same, if it's the same direction, and basically, if it's the same direction, and current lead is equals to, if it's, okay, so if it's same direction, hold on, let me see. If it's same direction, and the current lead count is equals to 10, right? Then we must continue. We must not move to the same direction anymore. Because we cannot move towards the same direction more than 10 times, right? So just now it's 3, right? Just now it's 3. Now we're gonna change to 10. But if it's different direction, and our current lead is, the count is less than 5. Basically, less than 4, right? So if we have moved in the direction for 3 times, or 2 times, or 1 times, and we want to turn, then we cannot. So we need to continue from here. So we cannot turn if we move in the same direction less than 4 times. Okay, so this is the change we have made. And let's try to run our code for puzzle 2. We get 47. This is 71. No, it's incorrect. Oh my god. Why? Okay, so here this is this case. Right, so this logic, if it's same direction, if it's current lead count is equals to, so 0, 1, 2, 3, 4, 5, 6, 7. Eight, 9. Huh. Again, what's wrong with the code? Let's figure it out together. Okay, so we 47. 1, 2, 3, 4. 4, 36. But why is 71? 1, 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Suppose we can go 9 steps and then turn. Then the more steps we go, the less number of 9s that we can incur, right? So why we turn over so fast? Did I misunderstand? Wobbly, and now can move a maximum of 10 consecutive blocks without turning. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. right? Turning 1, 2, 3, 4, 5, 6, 7, 8. Seems like they are turning earlier than it should. Path like this one. An ultra crucible minimum of 94. This route. Nine 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 nine. So 1, 2, 3, 4, 5, 6, 7, 63, 64. Yeah, 7 steps. Why is it 7 steps? Do I understand it wrongly? This is 10 consecutive blocks without turning. Minimum of 4 blocks in the direction before it can turn. Or even before it can stop. Or even before it can stop at the end. Okay. Or even before it can stop at the end. So I need to... The ending case also needs to be 4, right? Needs to be 4 in at least 4 blocks. Okay, so I guess in our ending condition, where's our ending condition? So here our ending condition, if we're gonna move to this one, and the current lead dot count is one more step will be at least 4, right? So this one is at least 3. So it has to be greater equals to 3. Greater equals to 3. Right? So at least when I move one more step is 4, then it's correct. So it has to be, the current lead account has to be greater than 3. Or greater or equal to 3. Let's see. No change. Even if I add this, doesn't make any change to the solution. But if I say at least... If I change this, doesn't change anything at all. Or maybe change to 5. 95. Greater than 4. 87. Greater than 3. I guess that's the... Huh. Zero, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, and then go down 1, 2, 3, 4. Turn 1, 2. So I need at least 4. What is wrong with this code? Okay, so I guess the same debugging idea that we had previously, we need to add the paths. Right? I'm not sure even this is helpful at all. Right? So let me undo this thing. So it's much easier for us to add in new field if we need to, right? So copy this one out. Okay. this here as well. And then finally here. Okay, so we need to record the paths. So I'll start with path is empty array. And then the path is basically path current lead dot path plus the next call next row. Try and print out console log current lead dot path. Okay, so we start with 0 0 and then move to this is column and row. Okay, let me stop this to make it row and column. Right, 0 0 1 2 3 4 9 10, and then we move down to 1 2 3 4 and it will turn. Oh no, okay. I think the logic is a bit wrong over here. Okay. So, basically we also need to know the next count is equals to this one. Okay, so just now the count, the logic is because we didn't consider whether the next move is actually turning direction or not, right? So we actually move all the way here and then we turn in, and then because we have moved down straight down for 4 times, we just assume that we just based on that count, not the next count, right? So actually is the next count has to be at least 4. That's the correct logic, right? It has to be at least 4. And then this is the next count like this. So if I save this and run, I get 71, which is correct, the answer over here, right? So this now the logic is correct. So let me remove the paths. We don't need this to help us anymore. Hopefully you don't need it in the actual example. Okay, so now let's use back this example. Copy this one out. Paste this in. Let's run this. We get 94, which is correct, right? And then let's finally copy the actual input. And let's put this in. And then run this. And it will take a while. Yeah, it will take a while. But hopefully this time around it's much faster than it was. We have spotted some of the problems previously and allow us to run much faster. Hopefully this time around, yes, we got it in 16 seconds. And so now the answer is 1010. Let's paste this in. Submit. And yes, that's the right answer. And so we have finally solved this day 17. Oh my god, how long does it take? Okay, so thank you for staying on so far and debug this problem together. Hopefully we have solved day 17 and we are moving towards day 18. So we're gonna see you next day. Bye bye.